All right, so the next piece is, in general, if the expected value of a game is negative, you can expect to lose money over the long run. Because we're talking about a game, so that's why we're talking about winning money or losing money. If the expected value is positive, you can expect to win money over the long run. So to go back to the previous example, our expected value was $1.40, so we're expected to win that on average. The difference is we just haven't taken into effect how much we actually paid to play the game. And so that's why that became negative, that 60 cents. Now, if the expected value is 0, it is considered a fair game, since neither the player or owner are expected to come out ahead over the long run. So casinos definitely do not play a fair game. All right, so let's do example 2. Let's talk about another game. A roulette wheel has 18 black numbers, 18 red numbers, and then the numbers 0 and 00, and they're green. In roulette, betting on a red is a 1-to-1 bet. And so what that means is if you put $5 down, you're going to win $5 or lose $5. Okay, so whatever you put down, you gain or lose. That is if you win. I just said that. Suppose you make a $10 bet on red. What are your expected net winnings? So what we're going to do here is we are going to create a probability model, or we can call it a probability distribution. So I'm going to make a list. I have my outcomes. Forgive that writing, it's atrocious. Outcomes. And then we have our net winnings. And then we have the probability of it happening. Okay, so our outcomes here are we either get a red or we don't get a red, so not red. That's the whole process of how this fun game works. Now, if you land on a red, you will be up $10. And that's why I said net winnings, okay? So we're not taking into effect that we put down $10. We're going to win that $10. Then if you don't win on a red, we're out $10. That whole 1-to-1 bet thing. Now, if we have 18 black, 18 red, and then 2 of these guys total, we have 38 possibilities. Well, there are 18 ways we can land on red, so that's 18 out of 38. And not red is, it is the 18 red and then these 2 greens, because they're also not red. And so that's why that would be 20 over 38. And one really nice thing is to make sure that you got it right is to add these up and make sure it comes to 1. And it sure does. All right, so let's do the expected value. Well, I'm going to do expected value. It would be plus $10, and there's 18 out of 38 chances of getting that, plus a negative $10, and there's a 20 out of 38 chance of getting that. And when we do that in our calculator, and again, I'm just relying on my handheld calculator just to not switch screens a million times. I'm going to go ahead, minus 10 times the 20 over 38. And this is money, so I'm going to round it to the tenths. Make sure you just pay attention to how my Open Math wants it. And it looks like about 53 cents. And so what that's telling me, because it's negative, okay, we can expect to lose, and I don't have to put the negative since I used the word use, 53 cents per game. And again, to be really clear, over the long run. This does not mean you play and you're going to lose 53 cents your first play. So if you sit there all night and you keep playing and you knew you should have walked away, you're probably going to end up losing. So what I'm going to ask you now to do is to see if it's sitting well with you, because example 3 is pretty straightforward. I'd pause this video and see if you can do example 3, and then start playing it again and see if you got the right answer. All right, so a bag contains 3 gold marbles, 6 silver marbles, and 28 black marbles. Someone offers to play this game. You randomly select a marble from a bag. If it is gold, you win $3. If it's silver, you win $2. If it's black, you lose $1. What is the expected value of this game? So I need to come up with a probability distribution. So just like we just did, here are my outcomes. Net winnings. Probability. And I probably didn't have to make this so big so I could actually write something. All right, well, total 3 plus 6 plus 28 is 37. So I have options of pulling a gold or a silver or black. Well, if I pull a gold, it looks like I win $3, so I'm going to put a plus there. And my probability would be there's only 3 golds, but there's 37 total in the bag. Silver, I win $2, and that is 6 out of 37. And then black, I lose $1, and that is 28 out of 37. So of course losing has a bigger chance of happening. And again, when you're doing this on your own, just to make sure it's correct, add those all up, make sure you get 37 out of 37, and I do. And so my expected net winnings, or expected value, however you want to say it. I like net winnings because then I know it's exactly talking about what you're winning. It's going to be $3 times that probability plus $2 times that probability plus a negative $1, or you could just write minus of that probability. I'm putting approximately because I'm going to have to do some rounding. So again, I'm going to my calculator, whatever one you like to use, because you'll always are allowed to use a calculator in this class. And I'm going to do plus 2 times 6 out of 37 minus 1 times 28 out of 37. And again, because it's money, I'm going to round to the hundredths. It's negative, and it's a money, 19 cents. So again, nice little sentence. On average, you can plan to lose 19 cents per game. Again, being really specific over the long run. Okay, so that's really good to know. Not that I ever want to encourage gambling, but hopefully this is encouraging you maybe not to, because you are seeing we just constantly are losing money, but to also just like walk away. All right, the next couple examples I'm going to put in the next video because it's going to be talking about insurance companies. All right, see you next time.